This is critical thinking in the brain and spinal cord, and here are the questions. Here is the first one where you have to identify the incorrect statement. Here you have to identify the correct statement. And here is a clinical problem, and you will be getting questions like this. So I have one example for you. So let's look at this first one where it asks you to identify the incorrect statement. So the first statement says the thalamus is the primary sensory relay station. Now this is a true statement. All sensory information that can be perceived which comes from the body, so it'll come from the body, travel all the way up. It is three neuronal. There'll be a synapse in the spinal cord or the medulla, then it'll go up, synapse in the thalamus, and then from the thalamus it goes to the sensory cortex, which is in the parietal lobe. So therefore this statement is true. Let's look at the next one, which says Tony's Wernicke speech area is damaged and hence he is not able to comprehend what people say. Now Wernicke's speech area is sensory speech, and this is present in both the parietal and the temporal lobes. Sensory speech means the ability to understand what people are saying, and then therefore when you understand what they're saying, your replies are coherent. Now, if his speech, this Wernicke's speech area is damaged, obviously he'll not be able to understand, comprehend meaning understand what people are saying. So this is a true statement. Now, you have to be careful understanding sensory speech and motor speech. Broca's speech area is the motor speech area. So the motor speech area is Broca's speech area, where in this situation the person's not able to speak properly. They can understand whatever anybody says, but when they try to reply, because the motor coordination is gone, they are not able to speak properly. In sensory speech, you don't understand what a person is saying. Your speech is, you can form your words normally, but because you don't understand what a person's saying, you talk nonsense at that time, because your response obviously doesn't match what the person's trying to say. So you have to be very careful, and you must understand the difference. The motor speech area obviously is present in the frontal lobe. Now let's look at the third statement, which says a sudden change in personality due to a brain injury indicates damage to the occipital lobe. Now this is incorrect, because the occipital lobe, its main function is to do with vision. Personality is taken care of by the frontal lobe, and you have that famous case of Phineas Gage. So a sudden change in personality is usually indicative of frontal lobe damage. So this is the incorrect statement. And let us look at the last statement, which says a blockage of the cerebral aqueduct will cause CSF, or cerebrospinal fluid, to back up in the third and the lateral ventricles. Now I want to show you this image which is there in your brain and spinal cord slides. And again, if you look at this image, you can see that we are talking about the cerebral aqueduct, and here this part here is the cerebral aqueduct, which connects the third ventricle to the fourth ventricle. You can see this here. So if there's a blockage here due to any reason, scarring or anything, you can see that CSF, which is produced in the lateral ventricles, as it is traveling down from the lateral ventricles to the interventricular foramen and coming into the third ventricle, it's not able to pass through and get into the fourth ventricle. So it'll keep producing CSF, and so it will not pass down. So with the result, what will happen is that these ventricles, the lateral ventricle and the third ventricle, will enlarge, and you will have what is called a type of hydrocephalus, which is known as internal hydrocephalus. So you can see this. So this is what the person will suffer from. So therefore, coming back to the question, a blockage of the cerebral aqueduct will cause CSF to back up in the third and lateral ventricles. It's a true statement. So the incorrect statement is this one. Let's look at the next question, where you have to identify the true statement. So let's look at all of them. The first one says an injury to T6 vertebra will injure T6 spinal segment. Now, this is incorrect. So when I say T6 spinal segment, it means the thoracic segment of the spinal cord. The reason being, you know that in adults, the spinal cord ends at the level of L1 and in children, it ends at the level of L3. So if you look at the spinal cord, and it ends at the level of L1 vertebra. But you know that the vertebral column, so if I was to draw the vertebral column all the way up here, so this is L1, so you have L2, 3, 4, 5, and then you have the sacrum up here. So the last spinal nerve, coccygeal one, comes out at the level of L1. So the spinal segments and the vertebral column, the vertebrae, they don't match up. The that which what I'm trying to say here is that the T6 vertebra does not lie against T6 spinal segment. In fact, it lies against another spinal segment. It usually lies against T8 spinal segment. So there is a formula that's used which you don't need to know, but usually we take it that in the cervical region you add 1 to the vertebra. So in other words, if it is C7 vertebra, it is C8 spinal segment. In the upper thoracic, you add 2. So if it's T6 vertebra, it becomes T8 spinal segment. But what I want to emphasize here is that the vertebrae and the spinal segments do not correspond to one another. So this is a false statement. The second one, which is injury to the cerebellum will result in memory loss. This again is not true because the cerebellum takes care of balance and equilibrium. And so in this case, this loss will not result in damage to the cerebellum will not result in memory loss. The person will have problems with balance, with muscle coordination and all of the other cerebellar functions, but not with memory. Memory is a function more of the cerebral hemisphere, the lobes of the cerebral hemisphere. The third statement, which is damage to the ascending tracts will result in motor loss. Now, this again is not true. And I want to show you here the spinal cord. And if you look at this, ascending tracts are also known as sensory tracts. So ascending tracts are also known as sensory tracts. Descending tracts are also known as motor tracts. They're called ascending because they travel up. They are carrying information to the brain, and you can see this blue line. So it's going up. The first neuron synapse is in the dorsal horn of the gray matter. Then it crosses over, travels up as a sensory tract, goes to the thalamus. Again, you can see the thalamus is a primary sensory relay station, and then it goes to the sensory cortex, which is present in the parietal lobe. And that is known as the post-central gyrus. It's called the post-central gyrus because it's behind the central sulcus, post-central gyrus. So sensory tracts are tracts which carry information to the brain. So when information is carried to the brain, it's ascending and it is sensory. Information which comes down from the brain and then goes out goes to muscles. So because it's coming down, we call them descending tracts, and they are motor fibers. And I also want you to see that all these tracts are present in the white matter. So damage to the ascending tracts will result in motor loss is also not true. So we had that these three statements were not true. And let's look at this last statement, which says Susan had an injury to the inferior end of the post-central gyrus, which resulted in her not being able to taste her food. And here I want you to look at the functional localization of the brain. So you can see that this is the central sulcus. In front of it is the precentral gyrus, which is the primary motor cortex. That is, motor fibers begin from here and go down. So this is part of the frontal lobe. Behind the central sulcus, this area is the parietal lobes, and this gyrus is called the post-central gyrus. And you can see here, you can see the gustatory cortex or the taste cortex, and that is present here in the parietal lobe at the inferior end of the post-central gyrus. So that statement is true. And hence, when we look at this question, the only true statement is this one. That means when she has an injury, she's not able to taste her food. Let's go to the next question, where this is a clinical problem. So it tells you that Jake suffered from a cerebral hemorrhage, after which it was noticed that he could not identify common objects placed in his hand with his eyes closed. So when his eyes were closed, if you placed a common object, he could not identify that. That is known as stereognosis. The ability to identify common objects placed in your hand by texture or anything with your eyes closed is known as stereognosis. So what he has is called astereognosis. Then the other symptoms that he has, he cannot find his way around the house, and he also combed his hair only on one side. So he kind of disregarded one side totally. So it says, which of the following areas do you think was involved in this neurological deficit? So let's look at that. So here, first of all, it says he had a cerebral hemorrhage. So obviously it was something in the cerebral hemispheres which were damaged. So it is not the white matter of the spinal cord that automatically rules this out. Also, it's not the cerebellum. One, because of this point here which says cerebral hemorrhage. Secondly, the cerebellum has to do, as we did earlier, with balance and equilibrium and muscle coordination. So it's not that. The medulla oblongata, it's not the medulla oblongata, because this is one of the areas which has vital centers for respiration, along with the pons for respiration and cardiovascular system. It also has cranial nerves emerging from that. So we don't have any specific cranial nerve mentioned here, so it is not this. Then the last two are to do with the cerebral hemispherical lobes. So let's look at this choice. The fourth choice is temporal lobe. Now it's not the temporal lobe, because amongst the functions of the temporal lobe are it's responsible for hearing or audition. It has the auditory cortex. It has the Wernicke's speech area, responsible for memory, and it is responsible for smell. So none of those are are mentioned here, so it is not the temporal lobe either. So it was none of these. And let's look at parietal lobe. Now, amongst the functions of the parietal lobe are it's a primary sensory cortex. It is also responsible for stereognosis. So you can see that is mentioned. People with parietal lobe problems cannot read maps. They forget their way around the house. They also tend to disregard one half of their body. So all of that is mentioned here. So therefore, the lobe that is mentioned, or the area that is that will be involved in this neurological deficit, is the parietal lobe. So therefore, this is the answer to this question.